Have you ever wondered how one mind can change the course of history? Today, we're diving into the world of Albert Einstein, the man who illuminated the corners of the universe with theories that transformed our understanding of time and space. From the famous equation 2 equals mc2 to the scientific puzzles that continue to spark curiosity, we'll uncover the life of this extraordinary genius. Get ready to discover the secrets of our favorite genius and learn about the profound impact he left on our world. Let's embark on our journey into Einstein's universe. Albert Einstein's childhood was remarkable in many ways, marked by characteristics and events that had a significant impact on his later scientific career. Birth and early life. Albert Einstein was born on March 14, 1879, in Ulm, in the Kingdom of Württemberg, Germany, which later became part of modern Germany. His father, Hermann Einstein, was an electrical engineer, and his mother, Pauline Einstein, was a pianist. Family and home life. He grew up in a Jewish family, though they were not deeply religious. The family ran a small business specializing in electrical equipment, which influenced Einstein's thinking about science and innovation. Early education. From a young age, Albert showed a strong interest in science and mathematics. He was passionate about scientific exploration and read extensively about science early on. Despite this, his school performance was not exceptional. He was sometimes known for his dissatisfaction with the traditional educational system, which led to negative feedback about his academic performance. School studies. In school, Einstein faced some difficulties with conventional education and demonstrated exceptional abilities in science and mathematics. However, he struggled to adapt to strict teaching method, which affected his grades. Impact of his studies on scientific thinking. At the age of 12, he read about the theory of relativity, a book that had a profound impact on him. He also began contemplating ideas about light, space, and time at a very young age. Moved to Zurich. After passing his high school exams, Einstein moved to Zurich to study at the Polytechnic Institute of Zurich, which later became the Swiss Federal Institute of Technology, in 1896. This step marked a significant turning point in his academic and scientific career. Einstein's childhood was filled with challenges and experiences that shaped his character and passion for science. Despite difficulties with the traditional educational system, he managed to excel and become one of the greatest scientists in history due to his deep passion and scientific curiosity. Albert Einstein's migration to the United States was a crucial step in his scientific and personal life. In 1933, after the rise of the Nazi regime in Germany and the increasing persecution of Jews, Einstein decided to leave Europe. He had previously worked at the Institute for Advanced Study in Berlin, but felt increasingly threatened by the Nazi regime. Einstein moved to the United States, where he settled at the Institute for Advanced Study in Princeton, New Jersey. At this institute, he conducted important research in theoretical physics and continued to develop his theories about time and space. In addition to his academic work, Einstein became active in social and political issues, including advocating for human rights and peace. This migration was not just a geographical move, but marked the beginning of a new and influential phase in his scientific career. Albert Einstein had a profound impact on modern physics through a series of scientific papers and theories that changed our understanding of the universe. Here's a summary of his most important papers and theories, along with his contribution to the development of the atomic bomb. 1. Major scientific papers, the Miracle Year 1905. In 1905, known as the Miracle Year, Einstein published 4 fundamental scientific papers. Special Theory of Relativity. In the paper titled On the Electrodynamics of Moving Bodies, Einstein introduced the special theory of relativity, which presented a new concept of time and space. The most famous result of this theory is the equation 2 equals mc2, which links energy and mass. Photoelectric effect. In a paper titled On a heuristic viewpoint concerning the production and transformation of light, Einstein provided an explanation of the photoelectric effect, which involves the emission of electrons from a metal surface when exposed to light. This paper was crucial in supporting quantum theory and earned him the Nobel Prize in Physics in 1921. Brownian motion, in a paper titled On the Movement of Small Particles Suspended in a Stationary Liquid, Einstein provided an explanation for the random motion of tiny particles suspended in a fluid, indirectly supporting the theory of atoms. Contribution to general relativity. In another paper, he provided equations supporting the concept of relativity in a cosmic framework, though it had less impact than other theories. General Theory of Relativity, 1915. General Theory of Relativity, presented in 1915. This theory generalizes the special theory of relativity to include the effect of gravity. The theory describes gravity not as a traditional force, but as a distortion in the fabric of space and time caused by mass. This theory was crucial in developing our understanding of gravity and the universe, successfully explaining phenomena such as the bending of light around celestial bodies. 3. Quantum theory and contributions. Contributions to quantum theory. Although Einstein was cautious about some aspects of quantum theory, he made significant contributions, such as explaining the photoelectric effect and introducing the concept of quantized energy. However, he disagreed with Niels Bohr on the interpretation of quantum mechanics, famously saying, "God does not play dice." 4. Contribution to the atomic bomb. Letter to Roosevelt. In 1939, Einstein wrote a letter to President Franklin D. Roosevelt, warning that scientific research might allow for the development of a nuclear weapon. This letter served as an initial push for the development of the Manhattan Project, which produced the atomic bomb during World War II. Later role. Although Einstein was not directly involved in developing the bomb, he became known for his conflicting views on its use. After the war, he was a prominent advocate for using nuclear energy for peaceful purposes only, and sought to limit nuclear weapons. 5. Later research. Search for a unified theory. Einstein spent the latter part of his life searching for a unified theory that would bring together the fundamental forces of nature. Although he did not succeed in achieving this, he laid the groundwork for many future theoretical physics studies. Albert Einstein revolutionized our understanding of physics through his theories and research. His contributions were crucial in developing new concepts about time, space, energy, and gravity, and he left a lasting impact on science and society. Albert Einstein passed away on April 18, 1955, in Princeton, New Jersey, where he was working at the Institute for Advanced Study. He was 80 years old at the time of his death. Einstein died from internal bleeding caused by a rupture of the aortic artery, a serious health condition. After his death, doctors chose to perform an autopsy and removed his brain for scientific research. Many studies were conducted on his brain later, which sparked some scientific and ethical controversy. Albert Einstein is remembered as one of the greatest scientists in history. He lived his life deeply engaged in research, theory, and social activism. His scientific and intellectual legacy continues to profoundly impact physics and science to this day.